Saurolophus, meaning lizard crest, was a large herbivorous hadrosaurid dinosaur, known for the solid backward-pointing crest on top of its head. It lived during the late Cretaceous period, approximately 70 to 68 million years ago, during the late Campanian to early Maastrichtian stages. Saurolophus belonged to the family Hadrosauridae and the subfamily Saurolophinae, which includes hadrosaurs without hollow crests. Fossils of Saurolophus have been discovered in western North America, particularly the Horseshoe Canyon Formation of Alberta, Canada, as well as in Asia, including the Nemegt Formation of Mongolia. This wide geographic range makes Saurolophus one of the few dinosaur genera known from both North America and Asia, suggesting land connections between the continents during the late Cretaceous. Saurolophus was a large and powerfully built dinosaur, reaching lengths of about 9 to 10 meters, 30 to 33 feet, and weighing around 3 to 4 tons. It could walk on all fours while feeding, but was also capable of moving bipedally when traveling or fleeing from danger. Its skull was long and flat, with a distinctive solid crest made of bone projecting backward from the top of the head. Unlike the hollow crests of Lambeosaurines, such as Parasaurolophus or Corythosaurus, the crest of Saurolophus was solid and likely used primarily for visual display, species recognition, and possibly signaling age or dominance within a herd. As a herbivore, Saurolophus fed on a wide variety of vegetation, including conifers, shrubs, ferns, and flowering plants. Its broad beak was ideal for cropping leaves and stems, while its advanced dental batteries, containing hundreds of tightly packed teeth, allowed it to grind tough plant material efficiently. These teeth were constantly replaced, ensuring the dinosaur could feed effectively throughout its life. Its strong jaws and chewing ability made it one of the most efficient plant eaters of the late Cretaceous. Saurolophus lived in large herds, which likely helped protect individuals from predators and allowed for complex social behavior. Herds may have migrated seasonally in search of food, especially given the changing climates of the late Cretaceous. It shared its environment with other large herbivores such as Edmontosaurus, Ankylosaurus, and Pachyrhinosaurus, as well as predators like Albertosaurus and Tyrannosaurus rex in North America and Tarbosaurus in Asia. One of the most important aspects of Saurolophus is its role in understanding dinosaur biogeography. The presence of closely related species on 2 continents supports the idea that dinosaurs migrated between Asia and North America via land bridges, likely across what is now the Bering region. Differences between Asian and North American species of Saurolophus also show how populations evolved separately after becoming geographically isolated. Today, Saurolophus is recognized as a classic example of a non-crested hadrosaur with a simple but effective display structure. Its strong build, efficient feeding system, and social behavior made it one of the most successful herbivores of the late Cretaceous. While it lacks the dramatic crests of some of its relatives, Saurolophus remains an important dinosaur for understanding hadrosaur evolution, migration, and herd dynamics. Alioramus, full genus name Alioramus remotus, with additional species such as Alioramus altai, was a slender, fast-moving tyrannosauroid dinosaur that lived during the late Cretaceous period, approximately 72 to 68 million years ago, during the Maastrichtian stage. It belonged to the family Tyrannosauridae, making it a close but more lightly built relative of Tyrannosaurus rex and Tarbosaurus. Fossils of Alioramus have been discovered in the Nemegt Formation of Mongolia, an environment that once consisted of river floodplains, forests and seasonal wetlands in ancient Asia. Alioramus was noticeably smaller and more gracile than other tyrannosaurids. It reached lengths of about 5 to 6 meters, 16 to 20 feet, and likely weighed around 500 to 1,000 kilograms, 1,100 to 2,200 pounds. Its most distinctive feature was its long, narrow snout, which bore a row of small, horn-like bumps on the top of the nasal bones, up to 8 in some specimens. These bumps were not used for combat, but likely served as display structures, possibly for species recognition or attracting mates. Its skull also contained more teeth than typical tyrannosaurids, suggesting it may have been adapted to hunt smaller, faster prey rather than tackling massive dinosaurs. As a carnivore, Alioramus likely preyed on smaller dinosaurs, juvenile hadrosaurs, and possibly fast-moving animals such as ornithomimids. Its long legs and lightweight build suggest it was a quick and agile hunter, capable of rapid bursts of speed. While it lacked the bone-crushing bite force of T-Rex, it compensated with speed and precision. Its arms were short, like those of other tyrannosaurids, but still muscular, with 2 clawed fingers that may have helped in gripping prey. Alioramus lived alongside much larger predators, especially Tarbosaurus, in the Nemegt ecosystem. Rather than competing directly, Alioramus likely filled a different ecological niche, hunting smaller prey and scavenging when possible. This division of roles would have allowed multiple tyrannosaur species to coexist in the same environment without constant competition. The discovery of Alioramus altai was especially important because it revealed that gracile tyrannosaurids existed alongside the more robust, heavy-skulled forms. This showed that tyrannosaurs were more diverse in shape and hunting strategy than once believed. Some scientists have even suggested that Alioramus represents a specialized lineage adapted for speed and precision hunting. Today, Alioramus is recognized as one of the most unusual and intriguing members of the tyrannosaur family. With its long snout, decorative nasal bumps and agile body, it demonstrates that not all tyrannosaurs were built like T-Rex. Instead, Alioramus represents a lighter, faster predator that thrived in the complex ecosystems of late Cretaceous Asia. Deinocheirus, full genus name, Deinocheirus mirificus, meaning terrible hand, was one of the most unusual and surprising theropod dinosaurs ever discovered. It lived during the late Cretaceous period, about 70 to 66 million years ago in the Maastrichtian stage. Fossils of Deinocheirus were found in the Nemegt Formation of Mongolia, an environment made up of river floodplains, lakes and wetlands. For decades, Deinocheirus was one of paleontology's greatest mysteries because it was known only from a pair of gigantic arms discovered in the 1960s. Once more complete skeletons were discovered in the early 2000s. Scientists finally learned what Deinocheirus really looked like, and it was nothing like expected. Deinocheirus was enormous, reaching lengths of about 11 meters, 36 feet, and weighing around 6 to 7 metric tons, making it one of the largest ornithomimosaurs ever known. Despite being related to ostrich-like dinosaurs such as Struthiomimus, it had a deep, heavy body, a long neck, and a broad, duck-like snout. Its arms were massive, over 2.4 meters, 8 feet long, with huge curved claws which inspired its name. Unlike most large theropods, Deinocheirus was likely an omnivore, not a pure meat-eater. Evidence from its beak shape, gut contents and bone structure suggests it ate plants, fish, small animals and aquatic vegetation. Fossilized fish, remains found near its ribcage, support the idea that it fed in rivers and shallow water. Its wide snout was ideal for scooping up food, similar to modern ducks or spoonbills. A tall sail-like structure ran along its back, formed by elongated neural spines, possibly used for display, temperature regulation, or fat storage. Deinocheirus lived alongside some famous predators, including Tarbosaurus, yet it was likely not easy prey. Its massive size, powerful arms, and strong claws would have made it dangerous to attack, rather than relying on speed like smaller ornithomimids. Deinocheirus likely depended on its size and strength for protection. Its legs were shorter and heavier than those of its relatives, suggesting it was slower moving and more suited to a semi-aquatic lifestyle. The Nemegt ecosystem was rich and diverse, filled with hadrosaurs like Saurolophus, armored dinosaurs, sauropods, turtles, crocodile-like reptiles, and pterosaurs. Deinocheirus filled a unique ecological role unlike any other dinosaur in its environment, acting as a massive, multi-purpose feeder along river systems. Today, Deinocheirus is considered one of the most extraordinary dinosaur discoveries ever made. Its transformation from a mysterious pair of arms into a fully understood, bizarre giant completely changed how scientists view ornithomimosaurs. With its humped back, duck-like snout, gigantic arms and mixed diet, Deinocheirus stands as a powerful reminder that dinosaurs were often far stranger and more diverse than anyone once imagined. Therizinosaurus, full genus name Therizinosaurus keloniformis, was one of the strangest and most distinctive theropod dinosaurs ever discovered. It lived during the late Cretaceous period, approximately 70 to 66 million years ago, in the Maastrichtian stage. Fossils of Therizinosaurus have been found in the Nemegt Formation of Mongolia, a region that once consisted of river floodplains, forests and wetlands. Although it was a theropod, the group best known for meat-eating dinosaurs, Therizinosaurus evolved into a massive herbivore or omnivore, making it a unique example of evolutionary adaptation. Therizinosaurus was enormous, reaching lengths of about 9 to 10 meters, 30 to 33 feet, and weighing an estimated 5 to 6 metric tons. Its most famous feature was its extraordinarily long claws, which could reach up to 1 meter, 3.3 feet in length, the longest claws of any known land animal. These scythe-like claws were attached to powerful arms and were likely used to pull down branches, strip leaves from trees, and possibly for defense against predators. Despite their frightening appearance, the claws were poorly suited for killing prey. The body of Therizinosaurus was bulky and deep-chested, supported by strong hind legs and a wide pelvis adapted for digesting plant material. It had a small head with a toothless beak and leaf-shaped teeth at the back of the jaw, ideal for cropping and processing vegetation. Its long neck allowed it to reach higher foliage, and its broad torso housed a large digestive system for fermenting tough plant matter. Fossil evidence suggests it may have been covered in primitive feathers, similar to its close relatives. Therizinosaurus lived alongside powerful predators such as Tarbosaurus, but it was likely not an easy target. Its sheer size, long reach, and dangerous claws would have made it a formidable opponent if threatened. Rather than fleeing, it may have relied on intimidation and defensive slashing to keep predators at bay. The Nemegt ecosystem is rich and diverse, containing hadrosaurs like Saurolophus, armored dinosaurs, massive omnivores like Dinochirus, and many smaller animals. Within this environment, Therizinosaurus filled a specialized niche as a high-browsing herbivore, feeding on trees and tall shrubs that other dinosaurs could not easily reach. Today, Therizinosaurus is one of the most iconic weird dinosaurs ever discovered. Its bizarre combination of a pot-bellied body, long neck, feathered appearance, and massive claws challenges traditional ideas of what a theropod should look like. It stands as a powerful example of how diverse and experimental dinosaur evolution could be, proving that not all terrifying-looking predators were actually hunters. Tarbosaurus, full genus name Tarbosaurus batar, was a massive carnivorous theropod dinosaur and one of the top predators of late Cretaceous Asia. It lived during the late Cretaceous period, approximately 70 to 66 million years ago, in the Maastrichtian stage. Fossils of Tarbosaurus have been found primarily in the Nemegt Formation of Mongolia, a region that once consisted of river floodplains, forests and seasonal wetlands. Tarbosaurus belonged to the family Tyrannosauridae, making it one of the closest relatives of Tyrannosaurus rex. Tarbosaurus was enormous, reaching lengths of about 10 to 12 meters, 33 to 39 feet, and weighing an estimated 5 to 6 metric tons. It had a large, deep skull packed with thick, serrated teeth designed for crushing bone and tearing flesh. Compared to T. rex, Tarbosaurus had a slightly narrower skull and longer snout, but it possessed the same devastating bite force and powerful neck muscles. Its forelimbs were short and muscular, with 2 clawed fingers, while its long hind legs allowed it to move efficiently across its environment. A long, stiff tail acted as a counterbalance when walking or turning. As an apex predator, Tarbosaurus hunted some of the largest herbivores of its ecosystem. Its prey likely included hadrosaurs, such as Saurolophus and Basbaldia, juvenile sauropods, and armored dinosaurs. Fossil evidence suggests it may have also scavenged when the opportunity arose, using its strong jaws to crack open bones for marrow. Its excellent senses, especially vision and smell, would have helped it locate prey over long distances. Tarbosaurus shared its environment with several unusual dinosaurs, including the giant omnivore Deinocheirus, the bizarre herbivore Therizinosaurus, fast ornithomimids like Gallimimus, and smaller tyrannosauroids such as Alioramus. The presence of multiple large theropods suggests niche separation, with Tarbosaurus dominating large prey while smaller predators focused on faster or smaller animals. The Nemegt ecosystem was lush and productive, filled with rivers, forests and wetlands that supported a diverse dinosaur community. Tarbosaurus likely played a crucial role in maintaining ecological balance by controlling herbivore populations. Whether it hunted alone or occasionally tolerated other individuals remains debated, but its dominance in the ecosystem is undisputed. Today, Tarbosaurus is considered one of the most powerful predators ever to exist. Often described as the Asian counterpart to Tyrannosaurus rex, it provides valuable insight into how tyrannosaurids evolved and diversified across continents. Its fossils have helped scientists better understand predatory behavior, biomechanics, and the spread of giant theropods across the late Cretaceous world. In the age after giants, the world grew quieter, but no less dangerous. Today's animals face shrinking lands, changing climates, and a planet shaped by forces beyond their control. In many ways, their struggle mirrors the final days of the dinosaurs, who endured fire-filled skies, darkness, and a world suddenly made hostile 66 million years ago. Yet life did not end. It adapted. From that catastrophe rose the ancestors of the animals we see now, carrying echoes of a prehistoric past in their bones, instincts, and survival. Dinosaurs are not just creatures of stone and film. They are the foundation of our world story, a reminder that life can fall, endure, and rise again, and that understanding the past is the key to protecting the future. In this world, there are multiple species of animals that lurk throughout every jungle and desert, most of which are small and powerless individuals that serve the ecosystem in a perfect balance. However, millions of years before, their ancestors had to deal with animals 10 times as strong as even some of the most powerful animals. We forget a lot of these magnificent creatures, but we remember most of them because of their beautiful fossil patterns, bone fossils, and much more. I hope you enjoyed our navigation through the history of the terrible lizards. Thank you, and good night.